later one, I think it's from about 96. This particular one actually came from a Daimler XJ13 V12. As you can see, the stud pattern has changed for the 6 litre. You can still see the bosses for the original 5.3 litre. I wanted a bell housing that would be suitable for both end blocks, the earlier 5.3 and the later 6 litre, or this particular 6 litre. So what I've done is I've designed it so that I can drill for either block. This is what sits at the other end of the bell housing. It's a ZF made by Quaife, so cosmetically similar to the original DS25 transaxle, but with modern internals. It's been modified and beefed up for the XJ13 application. The XJ13, in common with many Jaguars of the time, used the drive shafts as the upper link. So there's only a drive shaft and a bottom wishbone, with no wishbone at the top as they had in things such as GT40. So the transaxle has had to be modified internally to take the stresses imposed by the drive shaft being used as the upper link. It's got a normal manual good old-fashioned clutch release bearing, again as with the original XJ13, and very similar practice to what was used on the GT40. This is one of the cast bell housings, fresh from the foundry, heat treated to correct specification. Now all we need to do is machine it and see if we can fasten the transaxle to the block. The first job is to machine the faces. I'll start with the transaxle mounting face, then use that as the datum for machining the remainder. I shall be using my Bridgeport for the machining. It's actually a Bridgeport from the early 70s. The Bridgeport components of it are supplied from the States, and the remainder of the mill is manufactured by Adcock Shipley in the UK. It has a 48-inch table, 3-axis DRO. Hopefully there's going to be enough reach with the head to be able to machine the whole of the bell housing without having to fiddle around and relocate it. I have found that Swarf can fly around a bit, hence the plastic screens on either side. The X-axis is motorised, but the remaining axes, the Z and the Y, are manually controlled. I actually bought the mill off eBay. It was in a hell of a state when I bought it. But I found that it had actually been reconditioned in the, I think it was the early 80s, and since then it only saw use on machining wood. So the condition is actually excellent. I don't know whether this shot shows it well, but you can still see all the scraper marks on all of the slideways. The DRO is something I could really not do without. It makes it so much easier. Okay, first job is to fasten down the bell housing ready for machining. Okay, this is how I'm going to mount it. I've used a piece of scrap alley underneath each one of the clamps to protect the casting. It does look to me as if I'm not going to have sufficient travel in the Y-axis to drill all of the mounting holes for the transaxle. So what I may have to do is, at the moment it's set up so I know I've got access to all of this side, I can drill the holes that are required here. I think there's 1, 2, 3, 4 of them. The beauty of the Bridgeport is I can slide the whole of the head assembly back. I can then recenter the transaxle. I can check with the holes I've already drilled to make sure nothing else has moved and everything as it should be. Then I should be able to drill the remaining holes. Well, that's the plan. This is what I plan to use to machine the faces. It's a really nice indexable tool. I did have a nasty experience with one of these, in fact this particular one, where one of these had decided to come undone, which loosened the carbide tip, which messed up the component I was machining. So I always, as a matter of course now, just check that all of the tips are very, very secure. Okay. Okay. Let's attach this. Don't you always find when you've got a ratchet spanner, whichever way you put it on is always the wrong way first time round? You've always got to turn it over or change the rotation. Or is it just me? Right, now let's make some swarf. One thing I've learned to do is always wear eye protection. Please do the same. Okay. I know that the casting is 3mm too tall, so all I'm going to do is touch off and machine until I get a nice flat face. That's nice. I think what I'll do now is I'll take off 1mm from the surface. Okay, I'm happy with that. Nice even cut. No sign of any holes or imperfections in the alley. I'll just dress it very slightly around these edges. Of course I shan't drill any holes on this face until I've faced the opposite side and centralised it. But now I shall use this flat face as my datum to ensure that both sides are exactly parallel with each other. It's nice. I think while I'm here I may as well machine the top faces of these bosses for the bolts that attach to the transaxle. Okay, happy with these now. Okay, now how to mount this. I've only got one face so far that I know is flat, which I'm using as my datum. I now need to align this so it is parallel with the x-axis. Fortunately, because I'd already checked, I know that these two faces on the slideways here are absolutely vertical and parallel. I've got a flat face on the bottom of the casting here, so I'm using that as my x-axis. So hopefully, when I flip it around as well, if I do the same thing, that's going to give me the accuracy that I need for this application. Looks like we're going to run out of y-axis. Do what we can and then slide the head back. Finish off the rest. As soon as I've got a continuous surface, I can measure the distance. I need to check on the CAD drawing, but I believe it's about 100 mil. Of course, the mill is now attacking the camera. I've just moved the camera back very slightly. Don't want you in the way of the cutter. A lot of the casting runners are on this face. It's been quite roughly cut, so I'll need to get down probably another mil before I can get a continuous surface. That's 1 mil. That's what happens when you try to take too much off in one cut. Take it up 1/2 mil. It's about there. Okay, take 2. That's that face machined. I've actually been a little bit dumb here. It does happen. I was worried that I wouldn't have enough travel on the x-axis to drill all of the mounting holes. But in fact, the furthest back the last hole goes is round about here. So I've actually got plenty of space. This bit hangs down below the flywheel, so it doesn't actually need to be machined at all. So I can do it all in one go, which is nice. The next thing to do is to centralise the bell housing. I'm going to use the surface close to where it mounts to the transaxle to do that. Get it somewhere close to the centre by eye. Then start turning the mill at a very low speed. Lower than that. First with the y-axis, try to reduce the deflection. Down to within a couple of thou. Lock off the table and 0 the DRO. Now that I've zeroed it off on the casting, I'm going to take a very light skim around the circumference, hopefully keeping well away from my bed, so that when I flip it over I'll be able to centralise using the same face. I've got a nice band of about 5mm now that I can use as a datum. And then I can get on with drilling these holes. I measured the position of all the mounting holes using a 3D probe, so I know that the positions are measured to the required accuracy. Remember what I said about ratchet spanners? Damn things. Number 1. Right, that's all marked out. Now to drill through. These 6-litre blocks have got a mixture of imperial and metric threads. The threads that hold the bell housing on appear to be all imperial. 3/8 UNC. Nine and a half mil gives a nice tight fit on these 3/8 bolts. So I think what I'll do is I'll drill to 9mm and then sneak up on it with a reamer. How to ream it. Get in there now. These two holes are for the dowels. The dowels are actually still in the block. I need a very tight, accurate fit on these two. The dowels are 15.8mm. So again, I'll machine out 15mm with this and then take out the last 3/4 or so of a mil with a reamer. Okay. This is the Bellhousing back from the machine shop. My lathe was too small to swing the whole of this, so I've asked them to machine out this recess for the Bellhousing, the transaxle, sorry. And concentric to that, they've also machined out a clearance that I wanted for the flywheel. It gives me about 1.5mm clearance around the edge of the flywheel, which is perfect. Okay, a little bit of finishing off. I've got to drill out the holes, mounting holes for the transaxle, and then what I want to do is finish off some of these holes on this side, and then we'll see if it fits. Just check my clearances. All looks good. Everything seems to line up. Nice tight fit on the dowels. This engine is going in a car that won't be raced, so we're using a single plate organic clutch. It has been slightly uprated to cope with the torque from the extra capacity of the engine. This particular engine is a 6 litre. It's for fast road use. It's fully programmable fuel injection using Gen V throttle bodies. Throttle position sensor. There's an air temperature which I'm taking from one of the velocity stacks. Water temperature, and a crank sensor on the front. Although this is a single overhead cam engine, the velocity stacks are angled to the correct 60 degrees for the XJ13. Okay, that's them done. 7/16, down to the last half mil or so. I think I'll do that by hand. Nearly there. Perfect. Just break the edge. Now I just want to tidy up the edges here, get some nice flat faces, and then we'll have a trial fit. Last job on this, just machined out a small pocket to give clearance for the clutch release, and hopefully that will be that. Okay, it fits. Top two bolts have gone in beautifully. Nice fit. Yeah. Looks fine. Oh, spoke too soon. A little bit tight. Just run a reamer through. It goes in a bit tighter than I'd like. These are 7/16. That's it, beautiful. Okay, we'll fasten it up and then get the crane and see if we can get it on the block. That's it, it fits. Now all I've got to do is another fall. Fortunately, it's late on a Sunday now and I've got some cold beer in the fridge. The car in the background is going to be the tow car.